Hello students, I am going to explain static and dynamic characteristics of measurement system. Before going into the details of the static and dynamic characteristics of measurement system, first we'll see what is the necessity of studying static and dynamic characteristics of measurement system. See, when you're choosing any particular instrument for any application, or when you want to select some instrument for your project, then it is necessary to know the static and dynamic characteristics. Depending on that, you can be able to choose the particular instrument for the particular application. The performance characteristics of an instrument are mainly divided into two categories: static and dynamic characteristics. Static characteristics: the set of criteria defined for the instruments which are used to measure the quantities which are slowly varying with time or mostly constant, that is, do not vary with time, is called static characteristics. There is a question for you. What do you think? What are the different static characteristics of any instrument? Pause this video and think over it and write the answer for this question. There are 12 static characteristics of any instrument. First one is accuracy, second precision, sensitivity, linearity, reproducibility, repeatability, resolution, threshold, drift, stability, tolerance, range or span. These are the 12 static characteristics of measurement system. First one is accuracy. Accuracy is the degree of closeness with which the reading approaches the true value of the quantity to be measured. The accuracy can be expressed in following ways. There are 4 different ways of representing the accuracy. First one is point accuracy. Such accuracy is specified at only one particular point of scale. It does not give any information about the accuracy at any other point on the scale. Next is accuracy as percentage of scale span. When an instrument has uniform scale, its accuracy may be expressed in terms of scale range. Third is accuracy as percentage of true value. The best way to conceive the idea of accuracy is to specify it in terms of the true value of the quantity being measured. Precision is defined as it is the measure of reproducibility, that is, given a fixed value of quantity, precision is a measure of the degree of agreement within a group of measurements. Next characteristic is sensitivity. The sensitivity denotes the smallest change in the measured variable to which the instrument responds. It is defined as the ratio of the changes in the output of an instrument to a change in the value of the quantity to be measured, and it is mathematically expressed as change in output divided by change in input. And one more parameter in this is deflection factor, which is the inverse of the sensitivity. Next characteristic is linearity. Linearity is defined as the ability to reproduce the input characteristics symmetrically and linearly. Next characteristic is reproducibility. It is the degree of closeness with which a given value may be repeatedly measured. It is specified in terms of scale readings over a given period of time. It is defined as the variation of scale reading and random in nature. Drift may be classified into three categories: zero drift, span drift or sensitivity drift, and third one is zonal drift. Resolution: if the input is slowly increased from some arbitrary input value, it will again be found that output does not change at all until a certain increment is exceeded. This increment is called as resolution. Next characteristic is threshold. If the instrument input is increased very gradually from 0, there will be some minimum value below which no output change can be detected. This minimum value defines the threshold of the instrument. Next characteristic is stability. It is the ability of an instrument to retain its performance throughout its specified operating life, is called as the stability. Next is tolerance. The maximum allowable error in the measurement is specified in terms of some value which is called as tolerance. The next characteristic is range or span. The range or span is the minimum and maximum values of a quantity for which an instrument is designed to measure is called its range or span. These are the static characteristics. Now we'll discuss the dynamic characteristics of the measurement system. The set of criteria defined for the instruments which are changes rapidly with time is called dynamic characteristics. There are 4 dynamic characteristics. First one is speed of response, second measuring lag, third one is fidelity, and fourth one is dynamic error. We'll see one by one. First is the speed of response. It is defined as the rapidity with which a measurement system responds to changes in the measured quantity. It is called as the speed of response. Then second is measuring lag. It is the retardation or delay in the response of a measurement system to changes in the measured quantity. The measuring lags are of 2 types: retardation lag and time delay. A retardation lag, in this case, the response of the measurement system begins immediately after the change in measurement quantity has occurred. Time delay is, in this case, the response of measurement system begins after a dead time after the application of the input. And last is fidelity. It is defined as the degree to which a measurement system indicates changes in the measurand quantity without dynamic error. And last is dynamic error. It is the difference between the true value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. It is also called measurement error. Thank you.